Okay, for our next lesson, and we will have a big assessment on this, we are going to be talking about the idea of parametric equations. Now, parametric equations, you're still going to have your x and your y values, but we're going to have something called a parameter, and it's going to be your time t. The big difference with this is that we don't really know, given just x and y, when an object is at a certain place at a given time. So we really will try to be finding out a little more particular information with this. And here, keep in mind, when you're sketching a curve that's parametric, you're using increasing values of t. Your time is increasing. And so here we are going to use smaller arrows like we did with vectors, and we're going to trace out a specific direction or orientation for the curve. So let's go ahead and start with some problems. The first part, we always start off with doing some kind of sketch, and it will always start off with a t-chart of some sort. So for our first part of our t-chart, we're given very specific values of t, and we're going to take that t value and plug in for both x and for y to get specific values and generate our ordered pairs. So if I plug in -2, I get -2 all squared minus 4. So that's going to generate a 0 for us. And if we plug in with the y function, we get -1. So our first point that we're going to have is 0, -1. And then we move on to the next point. We're plugging in -1. And if I plug in a -1, I should get -3. And I'll get -1/2. So that's going to give me another point. So I go over -3, down 1/2, and so I have part of my curve here starting, and we would draw an arrow on that to note the direction. Then we're going to go ahead and we continue this pattern of filling in our t-chart. We're going to fill in 0, so I have -4 and 0. So I would plot my point -4, 0. And I'm going to continue my curve, and I need to draw in that arrow. And hopefully y'all's drawing looks a lot better than mine. Plugging in a 1, we get -3, 1/2. And so I go back to -3, up 1/2. And so we're continuing on around. And hopefully you see the pattern. We're just going to keep plugging in here. So for 2, when I plug in 2, I get 0. And if I plug in 2 over on the y part, I get 1. So at 0, 1, I have another point. And so I'm going to extend on over here. And again, drawing in my arrows to trace off our direction. And then we have our last point. Let's see. We're going to be plugging in a 3. And if we plug in 3, we're going to get 5. And then if we plug in for y, we get 3 over 2, which is the same thing as 1.5 or 1.5. So we can graph that. So we're going to end up way over on this other side, and we're going to have 5, 1.5. So let's go over 1, 2, 3, 4, 5, up 1.5, so somewhere up in here, and then we're going to continue the same motion. And so there's the whole idea of sketching a parametric equation. Hopefully it's not too bad. Let's do a couple more examples. Okay, so this next example, very similar to what we just went through. We are sketching the curve described by the parametric equations, and we still go through the same process of plugging in. So for the first one, I'm going to plug in -1. So for x, I get 0, and for y, I should get -1. And so again, I have the point 0, -1, and then we'll change over and go to the next point. -1/2, if I plug in -1/2 here, let's keep in mind that's going to give me 4 times -1/2 squared minus 4. So that -1/2 squared is actually a positive 1/4, and that's going to cancel with the 4. So I should have a positive 1 minus 4, so -3. And for the y, of course, -0.5. And so when we graph again, we go back 3, down 1/2. And again, we're going to do our curve, and we're going to have our arrow doing our direction or the orientation of the curve. The next value we're plugging in is 0, so I'm going to get -4, 0. And again, I'm going to plot -4, 0, continue my curve, making my arrows. The next value we're plugging in is 0.5, so we should get -3 and 0.5. So -3.5, so somewhere here, continuing on the curve. And again, make sure you put in your arrows. Don't just be drawing those curves. You need the arrows in. Okay, the next set of ordered pairs we have is 0, 1. And again, we're going to continue our motion. And then finally, the last point we have is 5 and 1. We're going to get 5 and 1.5. Okay. So we need to sketch that. 1.5, and again, we're still connecting those. And there's our curve, our particle, or not particle motion, our parametric equation. Sorry, wrong class. Okay, so that's about all we can do for the graphs of these. Let's continue on to something else. Here with example 3, we're going to do what's called eliminating a parameter. And with eliminating the parameter, what you'll be doing is we need to remove t from the equations and make this back into an x and y situation. So if you're eliminating the parameter, you're really removing the t. So we need to keep that in mind as we're working through these. Okay, so in order to do that, a lot of times it's easier to solve one of these two equations for your t value and plug into the other. It looks like, given these two equations, here solve for t in the second equations. So what that means is if I have y equals t over 2, and I solve that for t, then that means I need to multiply both sides of my equation by 2. And so those 2's will cancel. And so I have 2y equals t. And then I need to sub this into the second equation. And whenever I sub into the second equation, notice that I'm going to have x equals, but instead of having t squared, instead of having that t, I'm going to change that t to what we found t to be equal to, which is 2y. And that's all squared. minus 4. So I have x equals 4y squared minus 4. So that's the idea of eliminating a parameter. You rearrange one equation and plug into the other. It did not matter that I solved for the second equation and plugged into the first. You could have done it in the opposite direction and still would have been correct. All right, now we're really going to practice eliminating our parameter. And I know it says in the directions that we're going to graph showing the two equations graph the same. And I'm going to show y'all how to do that as well in the video. The first thing I would do is look at both of those equations and see which one's going to be easier to solve for t. And hopefully most of these, and just like in most cases, you're really going to focus on the one that has the x equals, because that's sometimes a little bit easier to solve for than the y. And so if I add 3 to both sides, notice I have x plus 3 is equal to t. And so my next step, what I'll do is take what I just solved for here, that t value, and I'm going to sub in over here everywhere I see a t. I'm going to replace it with x plus 3. So my new equation that has all the parameters eliminated would be x plus 3 all squared and plus the square root of x plus 3 and then minus 2. And please don't focus on trying to solve this down or simplify it anymore. That's not necessary. We've made the changes, and that's all we need to worry about seeing. When we graph these, we'll see that we do end up with equivalent statements. So the same for in part B. I'm going to solve for t, so I will subtract 2 and divide by 3. So I have x minus 2 all over 3. That's equal to t. And then I'll take my t value and I go and plug in over here. Everywhere I see a t, I'm going to change it out. So when we go and sub in, I'm going to have y equals 1 over and 2 times, and yes, I'm going to have this fraction in a fraction, and it is quite okay for that to happen. We're going to leave it all gunked up nasty. So we have all of this, and then minus 1. So we've eliminated the parameter. We've made that adjustment. Okay, so continuing on with the process, let's go back to the next one. Okay, so for part C, carrying on the same thing that we've been doing, we will be eliminating a parameter. So it looks like in this one, what we're going to do is end up multiplying both sides by 2. And if I do that, I have 2x is equal to t. And then I'm going to sub that in over here. So y equals sine of, and then that's going to be 2x plus 1, close the parentheses, and then minus 1. And that's all you need to do for that one. Okay, so for the next one, here the same idea. Now we do have the stipulation that t has to be greater than -1. That way we don't get any zeros in the denominator. So let's see what we're going to end up with this one. Okay, I have to get my marker going. Let's see, for this one, gracious, this looks terrible. Now, I would think about this as being x over 1, and I would cross multiply these. And in doing so, it looks like I'm going to get x times the square root of t plus 1, and that equals 1. I'm just cross multiplying. And again, I'm trying to solve for t, so I'm going to divide both sides by x. So I have the square root of t plus 1 equals 1 over x. And then I'm going to go through and square both sides. So if I square both sides, I get t plus 1 equals 1 over x squared. Because if I square 1, I still just have 1. And then I'm going to subtract my 1 over. So I have t equals 1 over x squared minus 1. Now I'm going to take all of that and plug in to the second part. So let's see what that final answer would look like, because all I need to do is plug in. So I have y equals, t is on top, so I need to put 1 over x squared minus 1. And then that's all over 1 over x squared minus 1, and then plus 1. And we can leave it like that, or you can go ahead and say, well, that's 1 over x squared minus 1 all over, and then those ones would cancel, 1 over x squared. But I wouldn't worry about simplifying much further than that. Now for the graphing part, I've gone through and shown you step by step of what to do. Again, remember on this, you do need to go to the home screen. That's where this first part is on the home screen. I'm going to write over. So you do need to make sure you're on the home screen. And then you will start a new document. And then you're going to have the options to come up here, and you're going to choose add a graph. And then to get to this part here, that is all in the menu. So you'll need to select the menu. And then once you do that, you see step by step from there how to type those in. And please verify that you do have the correct values substituted in. And once you graph them, you will see that you do have the same equations. So whether you type in the parametric and then you go and type in your rectangular where you solve for just x and y, you should generate the same graph. Okay, so here on this slide we see where we've typed in our equations without t. That would be this portion here, and the graphs do overlap. You ended up with the same exact graph. Now to get your second equation to type in, you will go back to your menu again. Anytime you see this screen here, it's from the menu. And now this time we need to select function, not your parametric, because now we are typing in the function. And you should see the graphs overlap each other. And please try this with all those examples that we just worked through. Okay, the next example that we have to work through, we need to sketch the curve represented by x equals 3 cosine theta and y equals 3 sine theta. So what we're going to do is see, well, what kind of shape does this make? Well, the first thing we would need to do, just like some of the earlier problems, we do need to simplify this down and get cosine by itself on one side and sine by itself on one side. So what we'll do is, for the first one, I'm going to divide both sides by 3. And I'm going to have x over 3 equals cosine theta. And then I'm going to have y over 3, because I will also divide by 3 over here because that's the coefficient of sine. Now, there's an identity, trigonometric identity, that y'all learned about last year, but I know we don't remember, so we're going to review that. That says sine squared of theta plus cosine squared of theta equals 1. And what we're going to do, since I know what sine of theta is and cosine of theta is, well, we can figure out pretty quickly what the squared version should be. So if I say cosine theta squared, then what I'm going to do is square the other side of my equation. So I get x over 3 all squared. And the same would go for your sine value. So if I do that, notice sine squared, well, sine squared, I would need to square both sides of my equation. So that's going to give me y squared over 9 plus x squared over 9 equals 1. And again, these values here are coming from me squaring both sides up here. That's where it's coming from. And notice I've generated an equation, and I'm going to move these 9s. I'm going to multiply those 9s over to this other side. And let's put x squared first plus y squared, and that's equal to 9. Now if we graph this, this is going to be the graph of a circle. This is going to be a circle with a center at 0, 0 and a radius of 3. That's what the graph is going to be. So we're going to have a particular circle. And yes, that circle looks pitiful. I do apologize. I can't draw. And the radius of this circle is going to be 3. The R here is 3. So that's another way that we can eliminate a parameter and see how to graph. And we will be using this type of problem later on. Last type of equation for us to look at, and this will be something that is important, is it's going to tell us to find a parametric equation for the given function. And so what we'll do, anytime we have to do that, it tells us in our directions here, we can simply let x be equal to t, and then we can go through and replace these and build two different equations. So the first equation is going to be letting x equal t, and then to get our y equation, we're just going to make that substitution, so it would be t squared minus 2 times t plus 3. And that's all you have to do. So now we've changed our equations over to a parametric equation. It almost seems too easy to be true, but this is how you do it. And again, over here for part B, you're going to let x equal t. And so that just means that your y equation, square root 2 times t minus 4 over 3 times t minus 1. Alright, and then in the final example, notice it wants us to change up a little bit and say, well, what would we get if we plugged in a t plus 2? Well, if we plug in a t plus 2, then let's see, that's going to change our x. It's going to be equal to now t plus 2. And so when we write out our equation, now we do have to be careful. That first equation is t squared, so we're going to have t plus 2 all squared minus 2 times t plus 2, and then plus 3. And then the same would be true for the next one. We're going to have x equals, and now we want t plus 2. And so that means that my y equation, we're going to have the square root. It's 2 times t plus 2 minus 4 over 3 times t plus 2, and then minus 1. Alright, I hope this helps. Please make sure you take some good notes on this, and we'll continue this on Monday.